Okay, here we go. Here are the notes for worksheet number 2. And we are graphing what? We're looking at these new type of functions, graphing exponential functions. So I'm going to review a little bit about, let me copy this down first and give you time to copy it as well. Exponential functions. All right, I'm going to give a quick review of what you saw in worksheet 1 and hopefully what you gained from that and what you learned when you did those tables. It was kind of a little bit more investigative. So here it is, and then I'm going to tie this in, connect it to something that we've learned in the past, and it's going to be easy. Okay, so just learn the rules and accept how this works, and it's pretty easy the way these things work. And they try to make things complicated, and you know what? Don't let them fool you. That's all I can tell you. All right, here it is. All right, so I'm breaking it down. So what did you gain from worksheet 1? From worksheet 1, first of all, remember, we want to have like a function like this. F of x is equal to like 3 to the power of x, or f of x is equal to 2 to the power of x. We want a base, and the exponent is over here, right? The exponent is actually where your variable is going to be. And when you've graphed these first 3, you realize they had something in common. Okay, whether you graph this one or you graph this one, or it's 4 to the x or 5 to the x, this is what they have in common. This is what they have in common. Right, because you did like the table of solutions, right? You pick points like this, and you plotted points. But honestly, if you looked at, there was one similarity. What was the similarity? Well, let's see, 1, 2, 3, and so on. If you look at all of them, when you pick x equals 0 on all of these, you get y is equal to 1. That's a very, very critical point. This is like your parent functions for these. Your parent functions, if you remember when we did parabolas, graphing parabolas, remember the origin, the vertex was at 0, 0. And then you kind of move that point. That was the critical point, 0, 0. And then, you had a horizontal shift and you had a vertical shift. This is your critical point for these exponential functions, because these are going to be like the parent functions. These are the parent functions. It doesn't matter if it's 2 to the power of x or 3 to the power of x. What do they all have in common? This point right here. But they all pretty much go like this. I'm sorry, for the ones that have a whole number here and an exponent, they shoot up like this, right? Because they increase exponentially, right? 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8, and so on. And then if you do 3 to the power x or 4 to the power of x, I mean, they're pretty close. They're pretty much right there. They're growing a little bit maybe a little bit quicker, but it's pretty much, I mean, the graph looks the same. So if it's 2 to the 3 or 4 or 5 to the x, whatever it is, it's gonna look like this. You just know that it looks like this, almost like the Superman ride. Have you guys been to the Superman ride in Magic Mountain? It just kind of shoots up like this. It just goes fast up, and then it comes down. Okay. But this is your critical point right here. This is like the origin, like for a parent. This is like the parent function, where this critical point is where? It's not at 0, 0. It's at 0 what? At 0, 1. 0 on the x, up 1. Okay? All right, so that happened to 2 to the power of x, that happened to 3 to the power of x, but then you had these other ones. You had these other ones that look like this. F of x is equal to 1/2 x, or f of x is equal to 1/3 x. And what I talked about there is, remember, we don't want a fraction. We want like a base, like a number and an exponent. So we learned from worksheet 1 that you can rewrite this and look at this in another way. 1/2 is really what? Is really 2 to the power of -1. 1/2 is 2 to the power of 1. And that -1 to the x, it will be, well, 2 to the power of -1x. Right? Right, because it's 2 to the power of -1 times x. So really it's going to be f of x is equal to 2 to the power of -x. So look here, what's the difference? This one is 2 to the power of x, or 2 to the power of positive x. Well, guess what? If it's a positive x, where is it? It is increasing from left to right. And from left to right, it is going up because it's positive. Right? And same thing here for this one. This would be what? F of x is equal to, well, 1/3 is what? 3 to the power of -1 to the power of x. Well, that's really what? That's really f of x is equal to 3 to the power of -x. See, I'm trying to make you look at this and kind of keep it as consistent as possible. And what I mean by consistent as possible is, here I got a positive number base, and then you're either going to have a positive exponent, right? The exponent is positive here. If it's positive, it's shooting up. The graph is increasing. It's going through 0, 0. When you graph these, guess what? They have something similar. Guess what's similar? Well, I don't even have to graph this other one, but when you did the table of solutions for either one of these and you picked x, y, guess what's the critical point? When x is 0, you still get 1. See, that's still the starting point. 0 on the x and up 1 right here. But see, these that have a negative x, what do they look like? They are doing what? They're not increasing from left to right. They're what? They're decreasing. So aren't they going this other way? They look like this. Right? So that's kind of like what they have in common and kind of like what they have difference. What do they have in common? This critical point is 0, 1. This critical point is 0, 1, right? If x is 0, I put a 0 here, -0, well, 2 to the power of 0 is 1. If x is 1, you get 1/2. If x is 2, you get 1/4. And it kind of starts, it gets lower this way. But when you put the negative numbers, see, when you put a -1, that negative and negative will 2 to the power of 2. And then so we know what the graph looks like. The graph looks like this. It's just kind of flat, and then it shoots up when it's positive. But it goes through this critical point. Here's what you got to know. If it's 2 to the power of 3 or 2 to the power of 4 or whatever it is, and it's a positive x, well, starting from the left, it is increasing. When it's a positive x, when this x is positive, the graph, this is what the graphs are going to look like, right? Like that Superman ride, right? It's an exponential function. It's not a constant function like a linear. No, it's increasing exponentially. When it's positively, when this is a positive x, it's increasing exponentially from left to right. And when it's a negative what? Well, it still goes through this point, right? These are like your parent functions. These are like your parent functions. We got a positive parent function, 2 to the x or 3 to the x or 4 to the x. The critical point is 0, 0. And the graph looks like this, shooting up. If it's one of these with the fractions, well, you rewrite it like this. And if it's a negative x, it's not increasing. Actually, it's decreasing. It's kind of going the other way. You guys see that? Same thing with 3 to the power of negative x. Okay, so that's the critical point. Okay? And now we're going to have translations. If you remember when we did the parent functions on quadratics and absolute value and all that stuff. Remember this? X minus 4 squared plus 3 or something like this. I know it's been a while, guys. I know. But let me just hopefully jog your memory here. Remember, if it's quadratic, it's a U shape, right? It's a U shape. And once we get that parent function, right, we got to start with something. We got to start with the parent function. But see, this one, the vertex, this vertex is here at the origin. Here, this one, the vertex is at 0, 0. Well, that's for these parabolas and the absolute values and the square root functions. Okay? And then remember, this was your horizontal shift, but you did the opposite, right? You would not go to x, positive 4. You moved it over here to, you moved this point over here to 1, 2, 3, to negative 4. Right? You moved it here. And then this was your vertical shift, remember? This was your vertical shift, and then you moved it up. Positive 3, 1, 2, 3. And then you moved it up. And that's why these are called translations, right? It's kind of like a shift, right? And you understood that. And you understood that. You accepted that. You understood it. And that's it. Everything means something. The squared means it's parabola. We know that this was the horizontal shift, but you do the opposite. So, oh, what did I do? I did it wrong, huh? Oh my God. We were supposed to do the opposite. Oh my God, look at me. Look at me. Yeah, we don't go to negative 4. We do the opposite. Oh my God, what am I doing? You go to 1, 2, 3, 4. My God, I caught myself there. You don't go to negative 4. Remember we did the opposite of that? You see, you learn from mistakes. This was a horizontal shift. And if it said negative 4, you didn't go to negative 4. You actually went this way to positive 4. Oh my God. That was horizontal, but then remember this number that's out here, this one was your vertical. Vertical. And then from there, okay, so now you move the graph here, but I don't want to draw it here because I know that's now its final resting point. Then you went up 3, right? Then you went up 1, 2, 3, then you went up 3. Oh my God, I'm glad I caught that. Okay, and then that was the way we learned, how to do these. I hope you guys remember that, right? We did that for quadratics, which are these quadratic. We did this for absolute value, which was the V shape. We did that for the square root function, the one that looks like an eyebrow. And then we did that for the cubic function, the one that looks like this. I know, it's been a while. Okay, but the point is, you had to start with the parent function first. You have to know what the graph looks like. Right, we know this one in this case was a U-shaped, but in this case the parent function, was a U-shaped, but then in this case the vertex was at 0, 0. What I'm telling you here for these exponential functions is what? I'm telling you the same piece of information. I'm telling you what? I'm telling you what the graphs look like, but there's kind of going to be two. When it's a positive x, from left to right, it's shooting up. It's growing exponentially. Like, think about like writing a sentence. Like today, I wish today was Friday. Tomorrow's Friday, but today is Friday. See, it's taking me up. Woof, it's going upwards. If it's a positive x, you're writing up, right? Most of us, when you write from left to right. Okay? If it's a positive x, it's going this way. But look, that critical point is not 0, 0. It's what? 0, 1. Okay, and then we got these ones that have these fractions. I don't want you to kind of look at it this way. I want you to just have a base and an exponent. And when that exponent, when that x is negative, that is not an increasing function, it's decreasing, right? But your critical point is still what? 0, 0. So what do we get from this first video? We know what the graph looks like. We know what the parent function looks like for positive x. And we know our critical point is 0, 0. Not 0, 0. What's wrong with me? 0, 1. 0, 1, not 0, 0. 0, 0 is the origin. And the same thing for, now we got kind of like another parent function for the ones that have the negative x. But the critical point is still 0, 1. But the graph does not increase from left to right. From left to right, the graph is what? Decreasing. It's getting, lower and lower. It starts high and drops low. This one starts low and then runs up high. Okay. We'll look at some examples on how you're going to see the problems, but pretty much know the parent function for a positive one. Know this critical starting point, 0, 1. Know what the graph looks like when it's, the ones with the fraction, but you rewrite it like this, and now it has a negative. So now it's decreasing, but that's the critical point. This is your parent function. From here, now we're going to shift this graph and we're going to move it around. But you have to first know when it's positive, what it looks like, and it's going through that point. When it's negative, what it looks like, and again, it's going through that same point. 0, 1 is the critical point. All right, take a look at the next video, and I'm going to just go through a couple of examples. You'll see how this is much easier than you're going to think. All right, thank you guys.